Hello people and welcome back to another video. In this session, we'll be going over a few problems on the concepts that we have discussed up until now, which involve confidence interval, hypothesis testing, Z-test, T-test, two-sample T-test, all of these concepts. We'll be looking at a few sample problems, and after probably this session and the upcoming session, in both the sessions we'll be looking at a few problems. Post that session, we will move on to our next topic. Just a few minor points before we actually begin solving a few problems. I highly recommend that once you read the question, you pause the video, try and solve the question by yourself. And after that, you can play the video where you can look at the way I am solving it. And eventually, you can also compare your final answer. In this way, you will come to know how much clarity you have on the concepts that we have learned up until now. Right? So with that said, let us go ahead and begin the problem solving session. The first problem says, what is the critical value from the standard normal distribution associated with a confidence level of 90%? I hope you guys have paused this video and tried this question by yourself, but let me just go ahead and try and solve it. So you have been given the confidence interval or the confidence level, as they say, as 90%. Or you can write it as 0.9, right? And you need to calculate the critical value. Now, the critical value is for the standard normal distribution. So for a standard normal distribution, you guys have studied the critical value is ZCL or Z critical. And the way we are going to find this out is, that if we have a standard normal distribution curve, let me redraw it once again. If we have a standard normal distribution curve and we have to calculate the Z critical given the confidence interval, as you guys know already, I've repeated this probably a couple of times that confidence interval is always double-sided. And so this area right here, this area in the middle, this is nothing but zero point 0.9. So if this is zero point 0.9 and the symmetric property of standard normal distribution says that the area to the left of the critical value is equal to the area to the right of the critical value. Therefore, each of this area, this and this, is 0.05. Cool. So now with this information, we need to calculate the value of Z critical. So we'll open our studio. Right. So as you can see that I need to calculate the value of Z critical. What is the area to the left of Z critical? It is 0.95, 0.9 plus 0.05. So we have been given the area to the left of a critical point. We need to find the critical point. And we have a standard normal distribution. So which function in R should we use to do this? The answer to that question is Q norm. So your answer would be Q norm of 0.95. This comes out to be 1.644. Let's check the answer. 1.645, 1 point, if you round it off to the third decimal place, you will get exactly that answer, 1.645. So this question is solved. Let's move on to the next question. Again, I won't be repeating myself again and again, but the general idea is you should pause the video, read the question, solve it for yourself, and then follow the solution with me. So the next question says the test statistic from a test of the following hypotheses, H naught mu is equal to 50 and H1, that is the alternate hypothesis, mu is not equal to 50, was calculated to be Z is equal to 1.35. You need to calculate the associated p-value. So in this question, let me quickly rub this off. In this question, we have our null hypothesis as mu is equal to 50. We have our alternate hypothesis as mu is not equal to 50. And we have been already given the test statistic, which is 1.35. Okay. Now, with all this information given, we need to calculate the associated p-value. Now, the p-value for this case, now what kind of a alternate hypothesis this is, or what kind of a test this is? If you see, our alternate hypothesis is we need to get the evidence for mu is not equal to 50, which means we need to get the evidence for for when mu is less than 50 as well as when mu is greater than 50. So we need to calculate the evidence for both sides. Therefore, this is a two-sided Z test. And for a two-sided Z test, if this is my curve, this is plus, this is my test statistic Z. I need to calculate the area on both sides, which is this and this. And so what we had seen previously is we need to calculate twice into probability of Z greater than or equal to mod Z. This is the area in concern for a double-sided Z test, and we multiply it by 2 because we know from the property of symmetry of a standard normal distribution curve that the area to the right of the test statistic is equal to the area towards the left of the other end of the test statistic, which means area to the right of plus z is equal to the area to the left of minus z. So let us calculate this. So we have to ultimately calculate this probability or this area where p is greater than, I mean, the point lies beyond the test statistic z. So we have been given the test statistic and we need to calculate the probability. Which function in R should we use? The answer to that question is yes, p norm. So what we will do is, now keep in mind that we are calculating the area to the right of that test statistic. Look at it carefully. We are calculating the area towards the right. P norm gives me the area towards the left. So I need to do 1 minus the P norm of Z and then multiply that complete thing by 2. So this will be 2 into 1 minus P norm of What was my Z value? 1.35. Let me just confirm that from the question. It is indeed 1.35. The value comes out to be 0.177016. Round it off, you'll get around 1770. Let's see what is the answer. The answer is 0.1770. This was question number 2. Let's move on to question number 3. It's the same question if you carefully look at it, but you need to calculate the p-value for a different alternate hypothesis. Now, what is my alternate hypothesis? My alternate hypothesis is mu is greater than 50. This is my new alternate hypothesis. So my area of consideration, rather than being both of these areas, will only be this one right here. If this is my test statistic Z, I need to find points that lie beyond Z because our alternate hypothesis is mu is greater than 50, right? So this is basically probability of Z greater than or equal to Z. Or I think I should write this Z because this is essentially capital Z or the point, and this is my test statistic. This Z is my test statistic, this Z is my point. So for a capital Z point here, this should be greater than this. This is the area I need to calculate. So again, P norm of Z gives me the area towards the left. To calculate the area towards the right, I'll just do 1 minus of that. So 1 minus P norm of 1.35, which comes out to be 0.0885. Let's see what the solution is. 0.0885. For the next question, again, we have the same question, but again, this time it is a change in the alternate hypothesis once again. So this time my alternate hypothesis is mu less than 50. So if you see from these three questions, your concept of single-sided and double-sided test will be extremely lucid because these three examples just represent those three fundamental scenarios that we have seen in our previous sessions. So this time it's very simple. We need to calculate the probability or the p-value for mu less than 50. So if it's less than 50, then we need to calculate the area to the left of my Z statistic, and which is directly given by P norm. So this time, no further complications, just P norm of 1.35. It gives me 0.911492 or 0.9115 if you round it off to the fourth decimal place. Let's see what is the solution. All right. Now let's move on to the next question. The next question says, we are interested in estimating the mean amount of rain last month in our county. It is known that the population standard deviation is 1.5 inches generally for the month of interest. 49 instruments that measure rainfall were placed throughout the county randomly. The sample mean from the instruments was 5.2 inches. Calculate the 95% confidence interval for the population mean of the rainfall last month in the county. So, first things first, when you read the question, it's always advised to write down all the details that the question has mentioned. So what all we have been given? We have been given population standard deviation 1.5, number of instruments 49, and sample mean 5.2. So n is equal to 49. Population standard deviation we have been given is 5.2. And we have been given sample mean is equal to, oh sorry, the population standard deviation is 1.5 and the sample mean is 5.2. All right. Now I need to calculate the 95% confidence interval. Now for confidence interval, you know, how do you calculate it? The confidence interval is given by estimate plus n minus margin of error. And I have also mentioned in one of my previous sessions that you can also write it and remember it as critical value into standard error. Okay, this is how you calculate the confidence intervals. Now for this case, my confidence interval will be estimate, which is sample mean, plus minus z critical into sigma divided by square root of n. Now first, you know you have all the values, you just need to calculate your z critical. And how do you calculate your z critical? You have been given 95% confidence interval. This right here, this is 95%. Okay, this is 95%. These two areas right here, these are equal. So if this is my critical value z, then what is the area towards the left of z? It is 0.95 plus 0.025, which is 0.975. So the area to the left of my critical value is 0.975, and I need to find the critical value. Therefore, the R function that will be handy in this particular situation is going to be Q norm. Also, the number of samples is 49, which means n is greater than 30. Therefore, the central limit theorem is applied and the sampling distributions of mean will start following a normal distribution. And so we can directly use Q norm in order to calculate my Z critical, which comes out to be 1.9599. Now you put all of these values in this particular equation to calculate the lower bound and the upper bound. So I have my X bar or my sample mean as 5.2. I have S as 1.5. I have N as 49. And I have, yep, that's it. I need to calculate lower bound, X bar minus Q norm of 0.975 into S divided by square root of N. Upper bound will be calculated in the exact same fashion. Just I need to change the minus sign to a plus sign. So the lower bound is 4.78 and the upper bound is 5.61. As you can see here, these are the values that represent my confidence interval. So 4.78 to 5.62, that is the answer that I'm getting for my confidence interval. So this comes out to be 4.78, pardon my handwriting, 5.62. Okay, let's see what the exact answer is, and that is what exactly we are getting. Let's move on to the next question, and let's try and solve the next question. The next question says the 95% confidence interval for the population mean was calculated based on a random sample of size n is equal to 100 as 55 to 65. What was the sample mean? So you, in this question, you have been given the sample size and you have been given the lower bound and the upper bound of the confidence interval. Let me remove the details of the previous question. You have n is equal to 100. You have lower bound is equal to 55. And you have upper bound is equal to 65. Let's write this. And it's asking me the sample mean. Okay. So, confidence interval, as we have just seen, is estimate plus and minus my critical value. In this case, my Z critical, because number of sample is 100, multiplied by my standard error. So both my sample mean and standard deviation are not given. We need to find the sample mean. We can calculate Z critical. It will be Q norm of 0.975 once again because it's 95% confidence interval. So I have been given my lower bound. This is X bar minus Z critical and upper bound is equal to X bar plus Z critical into sigma by root n. Now you can treat this as a linear equation in two variables. This is my first equation. This is my second equation. I'll subtract my second equation from my first equation. Let me remove all these down. So these are the two equations that we have. I get upper bound minus lower bound as twice into Z critical into sigma by root n. Now n is 100. So this is going to be 10 Upper bound minus lower bound, if you look at this, it will be 65 minus 55, which is equal to 10. 2 into Z critical sigma by 10. This is going to get cancelled here, and this will be 5. So you get sigma as 50. Now you put this sigma in any one of the two equations. Let's do that. So I'll take the equation of the upper bound. So my value of x bar will be upper bound minus Z critical into sigma by root n. This is nothing but equal to, my upper bound value is 65 minus Z critical, sigma is 50, this is going to be 10, so this is going to be 5. So this is going to be, if I do it using R, 65 minus Q norm of 0.975 into 5. Alrighty. Okay. Let me see if we have done any, if all our calculations are on point. By root n, we did not know sigma. So n is, because n is equal to 100, we get this as 10. This cancels right here. This is 5. Oh, no, 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 no. So this is where I made a calculation mistake. I'm so sorry. So if you look at this, I said right here that sigma is equal to 50. I missed to see that there is a z value over here as well. So technically this value of z critical into sigma, this is 50. So actually the value will be 65 minus z critical sigma is 50, and this is 10. This value will be 60. You did not, there was no need to actually calculate ZCL in this case, but let's see what the answer is. It is 60. So I'm so sorry, I made a calculation mistake over here. This value is going to be 50, and so which is why, which is from where you can just calculate it once again from that equation. This was a good question because this really would have forced you to apply a lot of mathematical concepts that you already know into the very novel concept of confidence interval that we have studied. So this was an extremely good question.